Hi, everybody. Today we will talk about financial models, basically interest, future value, present value, and how to compare two rates of return. Okay. So let's get started now. So financial models, section 4.7. All right. Let's see. I am going to share my desktop. All right. So let me see. Good. Now, so this is section 4.7, which is financial models. Okay, maybe financial models. There are two types of interest, simple interest and compounded interest. We won't really discuss much about simple interest, but we will discuss compounded interest in detail. Yeah. So the first one is simple interest formula. All right. So I is equal to PRT. So this is simple interest, meaning your principal is gets an interest, yeah, but your interest does not earn an interest. So what is I here? I is the interest after the amount is invested for 2 years. P is the principal, which is initial amount of investment or initial value. R is yearly interest rate. And T is the number of years the amount is invested. All right. Now, that's the simple interest. So we're going to talk about a compounded interest formula. So compounded interest formula. And of course, we will do examples on each. So there are two formulas. The first one is when the interest is compounded n times per year. Okay. So the formula is A is equal to P 1 plus R over N raised to the NT. And if the interest is compounded continuously, so if the interest is compounded continuously, okay, then the formula is equal to A is equal to PERT. So at this point, what we want to do is define what all the variables are. Yeah, okay. So A is the accumulated value, or This is called future value usually. So for both A1 and A2, yeah. P is the principal or initial value. And it's also called present value. All right. So R is the yearly interest rate. We usually change R to decimal. Usually changed from percent to decimal. Okay. Usually it's given in percent, but we will have to change it to decimal. And N, so this is specific for A1, so the first formula. N is the number of times the interest is compounded in 1 year. So if N is equal to 1, it's annually. And then if it is quarterly, oh, actually it's the other way around, right? So annually means N is equal to 1. For example, quarterly means N is equal to 4. And then daily means N is equal to 365, etc. Yeah. And then T is the number of years the amount is invested. Okay. So, and you know this E is actually, so E here, this is the natural number, approximately 2.718. So we will use the calculator value. Okay, so let's do an example. How do we actually get this formula? Yeah. So the easiest way is to look at specific examples. All right, so let's look at specific example. So Claudia invested, okay, $1,000, let's just say in Wells Fargo Bank. All right. How much money will she have after 1 year if, so let's consider two different scenario here. The interest follow simple interest. And B, if the interest is compounded quarterly. All right. Okay. All right. So anyway, let's answer these questions. So let's look at for simple interest. The amount of money after 1 year is A is equal to the principal plus the interest, and the interest is P times R times T. But in this case, T is equal to 1 because it's 1 year. Yeah. So it's actually 1,000 plus 1,000 times the rate is, the rate is 0.04. Oh, I forgot to write it. This is at 4%. Okay, so the interest rate here, I just added this one. Yeah, so the interest rate is 0.04. So times 0.04 times 1. So this is equal to 1,040. Yeah, so after 1 year, Claudia has 1,040 using simple interest. Okay. Now, let's answer the second question now. Yeah, so we will do it step by step. Okay. So this is what she has in the beginning of the year. So January 1st, 2014 is she has 10,000. Okay. Now in April 1st, 2014, so this is 4 months or 3 months after, yeah, Claudia will have 1,000. This is the principal plus the interest, which is 1,000 times the interest is still 4%, so 0.04 divided by 4. Why is it divided by 4? It's because it's the yearly interest rate. So since we calculate the interest 4 times a year, so each time the interest is not 0.04 but 0.04 divided by 4, because it's compounded 4 times a year. So this is quarterly. So quarterly means 4 times a year. Yeah? Alright. So if I could write this is equal to, so let me write it here. This is equal to 1,000. I factor out 1,000, then I will have 1 plus 0.04 over 4. Alright? Okay. So let's see. What about, so this is the principal plus the principal times interest. Maybe I should label this. This is the principal, and this is the principal times the interest. Principal plus interest. So principal times interest rate. Yeah, for in that quarter. Now, what about in July 1st, 2014? Well, then Claudia's money is this much, 1,000 times 1 plus 0.04 divided by 4. Right? So this is her principal. So then she will have interest. The interest is the principal. So P times R. Yeah. So the principal is 1,000 times 1 plus 0.04 divided by 4. And the interest rate, again, is 0.04, right? Divided by 4. Okay, I'm running out of space here. I think I had better use a different page. So let me copy this. Yeah, and then use a different page. So edit, cut. So I'm going to use a different page. Yeah. So it's clearer. Okay. So let me. So this is the principal, which is 1 plus 0.04 divided by 4 multiplied by the interest. Remember, the interest is equal to principal times rate times time. So the rate here is 0.04 divided by 4. Okay? Now, if I rewrite this, and I am going to see, all right, here, hold on. This one has one extra. Now, if I rewrite these, then I could factor out the same common factor, which is the principal. So when I factor out the principal, then what I have is 1,000 times 1 plus 0.04 divided by 4, okay? When I factor it out, then from the first one, from the first term, so from this term right here, okay, then I will factor out 1. From the second term, I could factor out 0.04 divided by 4. Okay. So practically, if you see, this is going to be equal to 1,000 times 1 plus 0.04 over 4 square. Alright? So that's what happens on July 1st, 2014. This is the amount of money that Claudia has. Well, we haven't really calculated what the value is, but this is what Claudia has. Okay? Now, what happens in October 1st, 2014? So, in October 1st, 2014, this is the principal. 1,000 times 1 plus 0.04 over 4 square. So, 1,000, 1 plus 0.04 over 4 square. That's the principal. Okay? But she invested it for another 3 months from July to October, so she earns the interest. And the interest is equal to the principal times the rate. So the principal is 1,000. Oh, I didn't have to put these parentheses. So 1,000 times 1 plus 0.04 over 4 square. So this is, again, this is the principal, multiplied by the rate. The interest rate is 0.04 divided by 4. Yeah? Okay, so if we factor out, this is the rate. Yeah. If we factor out the principal again, then we will have 1,000. 1 plus 0.04 over 4 square. This is the principal. And then when I factor out from the first term, I factor out 1. And from the second term, I have 0.04 divided by 4. So this is equal to 1,000 times 1 plus 0.04 over 4, so square times the same term, so this is cube. Yeah? Okay, now that's October. So now the last one, the last time it is compounded, it will be in January 1st, 2014. Okay, so how much does Claudia have? Well, this 1,000 times 1 plus 0.04 over 4 raised to the third power, this will be her principal. So this is the principal. But she invested the amount for 3 months, so she will earn the interest, which is 1,000 times 1 plus 0.04 cube, and the interest, so this is the principal again, multiplied by the rate, and the rate is the same thing, 0.04 over 4. Yes. So now we have 1,000, 1 plus 0.04, oh, I'm missing the 4 here, over 4, and then cube. And when I factor it out, then I will have 1 plus, here I'm left with 0.04 over 4. So this is 1,000, 1 plus 0.04 over 4 raised to the 4th power. Yeah. So when we calculate this is equal to $1,040.60. Okay. So in compounded interest, the interest gets an interest. So for each time it is compounded, the interest will earn interest. Whereas in simple interest, the interest doesn't get any. It's not calculated in the calculation. So the interest is calculated once Claudia takes the money out. just one time only. Yeah. So if you see here later on, this is where this formula come from. So in 1 year, the accumulated amount is A is equal to P. So P in this case is 1,000. 1 plus R over N. So raised to the N. Yeah. So N is the number of times it is compounded in 1 year. So how about in T years? So in T years, A is equal to P 1 plus R over N raised to the NT. So that's how we get the formula. Yeah? Because each time it is compounded, the interest earn an interest also. Okay? Alright. Okay, so anyway, let's do some more examples. I'm going to use a different page. Alright? So let's go to the next page. So the second example, okay. Find the future value. So actually when we calculate later on, we do not need to do it step by step for each 4 months or for each 3 months or for each year. We will just have to substitute the value using the formula, yeah, into the formula. So find the future value of, so A, if I have $30,000 invested at 7.59% for 4 years, compounded quarterly, okay, and B, $30,000 invested at 7.59% for 4 years, but this time it is compounded continuously. Alright, so in this case what we want to do is just use the formula. Yeah. So what is given? Let's see, for both we know that the $3,000 invested, so the $30,000 is the principal or initial value or present value. So P is 30,000 and R is equal to 7.59%, but we have to change R to decimal, 0.0759. And T is equal to 4 years. Okay. Now, depending on the question, so for find A, N is equal to 4. B, compounded continuously. So we have to use a different formula. Yeah. All right. So anyway, let's start. So to answer A, we will use the first formula, P 1 plus R over N raised to the NT. So A, which is accumulated value or future value, is 30,000 multiplied by 1 plus 0.0759 over N. N is 4 raised to the 4T. So T is 4 and N is 4 also because it's compounded quarterly. Okay? So this is 30,000 multiplied by 1.01875 raised to the 16. So then we will calculate. So what is raised to the 16 is 1.01875 only, not 30,000 raised to the 16. So this is 40,383 and 43 cents after 4 years. Okay, so B, A is equal to PERT. Yeah, so after 4 years, if this is compounded quarterly. Alright, so now let's talk about the one in which it is compounded continuously. Yeah, so P in this case, this is, let's see, P is 30,000. And then E is the natural number E. Raised to the R is 0.0759 times T. T is 4 years. So this is equal to, when you calculate, this is 40,495.76. So let's use the units here. So we need to use the units. 40,495.76 after 4 years, compounded continuously. Okay? Alright. So if the compounding is continuous or more time and the same interest rate, and it's compounded more times, then the amount is more. So this is compounded continuously. The amount, the accumulated value is bigger than when it is compounded quarterly. Yeah, it's always like that. Yeah. Okay. All right. So let's do another example. All right. So find the present value of, now there are of $2,000. Maybe I should just write them all together. So the same amount, $2,000. After 3 years, at 5% compounded, so A, compounded daily, and B, okay, so B compounded continuously. Okay, so basically this question is a little bit confusing. So find the present value of $2,000 after 3 years at 5%, meaning of the amount $2,000 after 3 years. So after 3 years, the amount is $2,000. Yeah. So maybe we should find the present value of the amount $2,000. So $2,000 is actually the future value. Yeah. So let's look at what is given. So given the future value is $2,000. T is 3 years, and the interest rate is 5%. So we have to change it to decimal, 0.05. Okay. Find P if N is equal to 365. So what is the present value if it is compounded daily, and B, find P if the interest is continuously compounded. All right, so let's answer it on the next page. So for A is P 1 plus R over N raised to the NT. All right. So we have $2,000 after 3 years. We don't know the P. We have 1 plus R over N. R over N is 0.05 raised to the, over 365 raised to the 365 times 3. So 3 years. All right. So let's copy these and then continue to the next page. Okay, let me copy this. And then we will continue to the next page. All right. So this is $2,000 is equal to P, and then this is 1 plus 0.05 divided by 365 raised to the 1095. Okay, so to solve for P, what we'll do, all right, is divide both sides by 1 plus 0.05 divided by 365 raised to the 1095. Okay, so this is the answer of your P. So when we use calculator, P is equal to 1721.43, and this is our present value. All right, so yeah, so if we need to save $2,000 in 3 years, so if we need $2,000 in 3 years, we know we need $2,000 in 3 years, then this is how much we should save now. Yeah, if the interest is compounded daily. Okay. All right. Now B, what about if the interest is compounded continuously? So most likely we will have to the P will be less. Yeah. So B, A is equal to PERT. So we know A, after 3 years, we have $2,000. We don't know the principal. We will multiply 0.05 times 3. So 2,000 is equal to P E 0.15. And then we divide both sides by E to the 0.15. Alright, so P is equal to, well, this is 2,000 E raised to the negative 0.15, or you could just divide these instead of changing it to a negative exponent, and this is equal to $1,409.38. So this is the present value that we need. So just say if the interest is continuously compounded, how much money do we need to save now so that in 3 years we have $2,000? So this is the amount, 1,409.38 is the one that we need. Okay? All right. Good. Anyway, more problems, a little bit more examples. Yeah. So next, example 3, or actually example 4. How long does it take for the money to double at 4.5% if the interest is compounded quarterly? So let me write down, maybe I should say if the interest is compounded quarterly, and B, if the interest is compounded continuously. Okay, so these are two different questions. So let's write down the given. So let's do it separately for A. Yes, or actually we could do it together. The money to double. What does it mean? So it means that the accumulated value is 2 times the principal. So double means the A is 2 times the principal, and we know the rate is 0.045, 4.5%. Yeah. So in this case, what we want to do, so find how long is T, right, when N is equal to 4, meaning the interest is compounded quarterly, and B, how long when the interest is compounded continuously. So we will use the other formula. Continuously, okay? So answer, A. A is equal to P multiplied by 1 plus R over N raised to the NT. So practically I do not need to know what the principal is, but I know that the accumulated value is 2 times the principal. Okay, so 2P, so substituting 2P for A is equal to P 1 plus 0.045 divided by 4 raised to the 4T. Alright, so the P cancels. So this is equal to 2 is equal to 1 plus, okay, 0.045 divided by 4. I'm sorry, 1 plus 0.045 divided by 4. This is 1.01125 raised to the 4T. Well, this is an exponential equation, so we could just take logs of both sides or ln of both sides. It doesn't matter. Okay, so in this case, to solve for t, we have to bring the t down. So ln both sides, or log base 10 both sides. So ln 2 is equal to 4t times ln 1.01125. And then we will divide both sides by, to solve for t, we will divide both sides by 4 ln 1.01125. So this one divided by 4 ln 1.01125. Okay, so you have to be careful when you use your calculator. So t is approximately, okay, so t is approximately 15.5 years. Okay, So when you use your calculator, probably you need to put parentheses here. So ln2 divided by parentheses 4 ln 1.01125. Okay? So then we get the t. Yes. Now, what about if it is continuously compounded? So it's the same thing. We will use the other formula. Yeah. And your accumulated value is 2p is equal to p e. R is 0.045 times t. And the p cancels. How do we solve for t? Well, we have to bring down the exponent. So we will take ln both sides. So ln here, yeah. Maybe I should rewrite it first. Hold on. So this is p, and we're canceling the p. So let's write. So 2 is equal to e to the 0.045 t. Well, the t is on top, so we will bring it down. So ln and ln. Okay. So ln2 is equal to 0.045 t times ln e. And we know that ln e, this is equal to 1. So ln e is 1. So we will divide both sides by 0.045. So t is ln2 divided by 0.045. That is approximately 15.4 years. Yeah, approximately. So if the interest is compounded quarterly, it takes a little bit longer, 15.5 years. But if the interest is compounded continuously, it takes a little bit shorter time. Yeah, only 15.4 years. Okay. All right. Now, almost the last one. So we will talk about a little more about rate of interest, how to find the rate of interest, and then the effective rates of returns, and then that will conclude our discussion. So let's do one more example, number 5. All right. So the question is asking now is what rate of interest? So what rate of interest is required, okay, to double, so to double a quantity of money compounded continuously in 12 years. In 12 years. So what rate of interest is required to double a quantity of money compounded continuously in 12 years? So given, again, to double just mean the accumulated value is equal to 2p, yeah, compounded continuously, and then t is 12 years. Compounded continuously. Alright. And we need to find R. Okay? So since this is compounded continuously, then we have to use the formula A is equal to P ERT. So A is 2P is equal to P E. R we don't know, but T we know. This is 12. And again, we will cancel out the P, divide by P both sides. So 2 is equal to E raised to the 12th R. How do we solve for R? Well, R is the exponent, so we have to bring it down. Use ln. Okay, so ln2 is equal to 12R times ln E. And ln E is 1. So this is 1 here, ln E is 1. So in order to solve for R, we will divide by 12. So R is ln 2 over 12, and it is approximately, okay, so R is approximately, let's see, 0.0578. Change it to percent, 5.78%. Yeah. So if the interest rate is 5.78% and compounded continuously in 12 years, the amount will double. Yeah. So this is the interest rate to double amount in 12 years if it is compounded continuously. Yeah. Okay. Let's see. Now, we still have a little bit more, which is comparing rates. So what we're going to talk about is effective rates of return. So we're comparing rates. Yeah. Okay. So suppose, who is it? Daniel wants to open an account. Okay. So bank A, there are 3 banks he's considering. So bank A offers 5% daily, interest compounded daily. Okay, so bank A, 5% compounded daily. How about bank B? A little bit more. So bank B offers 5.03% compounded quarterly. So I'm just going to copy this, compounded quarterly. And bank C offers 4.989% of interest, but in this case, this is compounded continuously. So the question is, which bank offers the best deal? Which bank of these 3 offers the best deal? Alright. So this is the question that requires the knowledge about effective rate of return. So we will write the 2 formulas to compare the interest. So effective rates of return. Yeah, there are 2 formulas. The first one is for compounded n times per year. So RE, so the formula is RE, meaning effective rate of return, is the interest portion only. 1 plus R over N raised to the N minus 1. Yeah, so this is the formula, the interest portion only in 1 year. What about the one for compounded continuously? So which one is the interest portion? So this is effective rate of return. This is just e to the r. So it's not e to the rt because this is in 1 year minus 1. Yeah, so we're comparing only the interest portion. Alright, so anyway, let's talk about it. So we're comparing 3 banks. So bank A, alright. So our effective rates of return is 1 plus r over n minus 1. So this is 1 plus 0.05 divided by 365 minus 1. So if you use your calculator, this is 1.05127 minus 1. So this is 0.05127. So the effective rates of return, if I write it in, so this is 5.12, I'm sorry, hold on, 5.127%. This is the effective rate of return for bank A. Okay? Now, how about the second bank? So let's calculate for bank B. So effective rates of return is 1 plus r over n minus 1. So 1 plus 0.0503 over 4 minus 1. So this is 1.05126 minus 1, 0.05126. So this is, writing it in percent, is 5.126%. Now let's see about bank C. This is the one that gives continuously compounded. Yeah. Okay, anyway, this one's supposed to be straight. So bank C, RE is e to the r minus 1. This is RE, by the way, is effective rate of returns. So e to the 0.4989, 0.04989 minus 1. So this is equal to 0.05106. Okay, so how many percent is this? This is 5.106%. Okay. All right. So which one gives the best return? Obviously, it's bank A. This gives the highest return. So Daniel should choose bank A. Why? Because it gives the highest return. Okay. So actually, this formula is quite useful when comparing more than one rate. So which one's better? Yeah, a 5% compounded daily, or 5.03% compounded quarterly, or 4.989% compounded continuously. Yeah, so we use effective rates of return. Okay, let's see. I guess we are actually finished with 4.7. So we practically did a lot of examples on using the two formulas for compounded n times per year and compounded continuously. Okay, so I guess I will see you next time, or I will see you in class this Friday. Okay guys, I'm going to end the discussion now. I'm going to leave the room. Okay.